210, okay, percent change. The first thing to note is just what is it? A percent change. A percent that something is changing is the ratio of the amount of change to the original amount that something was. Okay, so it's the amount of change over the original amount you started with. Okay, that change can be an increase or a decrease. So it could be something went up in price or something went down in price. Usually price is what you're going to be looking at today. It's not always price. You'll see on the letter B down there, it's precipitation. What was the percent of change in rainfall in a year? But a lot of times we relate it to money. So here's what you need to pay attention to. When we talk about the amount of change, okay, increase or decrease, we always want it to be the positive number that we're working with. But then you can think of it as it was a decrease in percent or it was an increase in percent, okay? But we're not gonna plug negative numbers into these. So what you need to make sure of is when you're doing an increase, you take the new amount, the increased amount, minus the original amount. If it's a decrease, you're gonna do the original amount and subtract the new amount so that we avoid negatives in this setup, okay? So we're gonna start with percent decrease. And this one, I kind of walked you through it piece by piece a little bit. Here's what it says. A coat is on sale. The original price is $82. Are we being unkind?
No.
The original price of your coat is $82. The sale price is $74.50. What is the discount expressed as a percent change? So the percent that item changed is what we're trying to figure out, okay? So the first thing to note is the cost of this thing going up or down? It's going down. It's decreasing in price. So when it is going down, we want to take the original amount and subtract the new amount. So what was our original price? 82. So we're going to go 82. So finding our change is 82 minus 74.50. Okay, that is the number. Anyone know it?
It's like $8.50.
So if you plug it into your calculator, it's 7.5. That's $7.50 off of the amount, right? So it comes out to 7.5. How you figure out the percent that it changed is that amount of change, that 7.5 or 750 if it bothers you to take the zero off, divided by your original cost. What was the original cost? The 82. Okay, don't divide it by the new cost, the 74.50, and that you just plug into your calculator. So 7.5 divided by 82, and you get this number, 0.09146, and so on and so forth, okay? The question they asked is, what is the discount expressed as a percent change? So I might add a fourth step here and just say, turn into a percent. Okay, and the way you do that is by multiplying by 100. So if I multiply this by 100, 0.09 becomes about a 9 point, did it say word around? I didn't say word around. We'll just call it a 9%. We'll round that to 9%. Was it an increase or a decrease? Decrease. So this is a 9% decrease in the cost of that coat. Okay, a 9% decrease. All right, so look at the next one. This one I didn't give you the steps piece by piece, but you're doing the same process. The average monthly precipitation for Chicago, Illinois peaks in June. So they get their most rain in June at 4.1 inches. The average monthly precipitation in December is 2.8. What is the percent decrease? This is important, how they ask it, from June to December. So what is your original amount? This is your original, okay? It doesn't matter the order they gave it to you in. It matters what they're asking of it. Now, they gave it to you in the same order they asked it on this one, but just pay attention to that. Your original amount is like what you started with. They're saying you're going to start in June, okay? So that's your original, and go to December. So what is your amount of change?
1.3.
Right, you go 4.1 minus 2.8, and then we're going to divide that by which of those numbers? The 4.1. So 4.1 minus 2.8 is 1.3 divided by 4.1, and that you can just plug into your calculator. You should get 0.31707. So if I treat that like a percent, to the nearest percent, what would that be?
32.
About 32, because this is 31.707%. So if we're going to round to a percent, I would say that's about a 32%. And this is a decrease. The amount of rain went down from June to December. Not likely to be the case for us. Although our June was our June rainy? Our August was rainy. I don't remember. That was August, I think. That was August. Khalees. Yeah, like I think I'll try to remember on the test to tell you where to round, but yes, because it's a number that just keeps going, so you kind of have to round. The nearest percent is typically good. Okay, so those are percent decrease, right? The number was going down. These next ones are percent increase, okay? Pretty much the same process, but you lay it out a little bit differently. Okay, so this says a store buys an electric guitar for $295. They then mark up the price to $340. What is the markup expressed as a percent change? Your top number, your amount of change is what minus what?
340 minus 295.
Yeah, so bigger minus smaller, okay? What's your original amount?
295.
The $295. They bought it for $295. Then they made the change to increase the amount, okay? So you're going to plug 340 minus 295 in. So you get 45 over 295. And then you're just going to divide that. And you get this number, 0.1525. So rounded to the nearest percent, that's approximately what percent? About 15%. Was that an increase or a decrease? That is a 15% increase in the price of that guitar. We would say they have a 15% margin. That's what they're making on the guitar.
So like whenever we do like problems like these, do we always put like about
I mean, if you don't put the squiggles, I don't care.
what
Yeah.
about the word?
No,
So you just say 50.
you can just say 15%. Yeah, that's fine.
You have to put increase and decrease.
You will have to tell me if it was an increase or a decrease. Yeah. Yeah, make sure you specified, is this going up or is this going down? Okay, so then letter B here. How about try this one on your own. In 1 year, the toll for passenger cars to use a tunnel rose from $3 to $3.50. What was the percent increase? Oh, I think I have another little one.
I got really funny this summer.
You what?
I got 0.16 for people. So
That's okay. Round that to the nearest percent. Yeah. All right, so what percent?
17%.
About 17%. So you're going to take the bigger minus the smaller over which number? The starting amount. Doesn't have to be the smaller amount, right? It might be the smaller, it might be the bigger. Over the starting amount. So if it started at 3, that's the one we're putting it over. So this is going to be 0.50 over 3. So 50 cents divided by 3, or 0.5 divided by 3, comes out to 0.1666, right? So 0.1 with the 6 repeating. So if you round that to a percent, that's about what percent? About 17%, and this was a increase. Okay. Questions on that? Okay, I think you'll see that this next idea is oh so very similar, okay? The way they lay it out is maybe a little bit different. I would say just keep doing it the way you've been doing it, really, in my opinion. There's something called relative error. It's like saying, relatively speaking, we're off by about this much in our calculation potentially, okay? So it is the ratio of the absolute value, those are the bars, right, of the difference, that's subtraction, of a measured or estimated value and the actual value that it was. Okay, so we're saying like, how far off were we? What is the relative error that we made in our calculations? Okay, so here's the deal. You have this setup, absolute value of the estimated amount minus the exact amount. What happens with absolute value? What does absolute value do to a number?
It makes it positive.
It makes it positive. Okay, so here's the deal. Do you always have to do estimated minus exact and take the positive version of it? No, you can always do the bigger one minus the smaller one, and it will be the positive version of it, okay? So if you like that better, really what you're doing is the same thing as the last setup. You just subtract bigger minus smaller so we don't end up with a negative. This is what's different. This number is not your original amount anymore. It's the exact amount. So there's an estimated amount and there's an exact amount. You always want your exact amount to be your denominator, okay? So let's take a look at this. It says, finding relative percent error, you estimate that you are 5 feet 3 inches tall. You estimate 5 feet 3 inches tall, okay? When you go to the doctor, you measure at 5 feet 1.5 inches tall. What is the percent error in your estimated height? Anyone know the first thing you have to do with those numbers?
5.3 minus 5.15. Wait, turn them into
We're going to just use one set of units, right? So feet and inches is not great. We're going to just use inches, okay? What is 5 feet 3 inches as inches? 63. 5 feet is 60 inches, right? 5 times 12, and then add the 3. So 63 inches versus, what's 5 feet 1.5 inches? What? 61.5, right? Okay, so don't use different units. Keep it just in one set of units for that. It's going to simplify your life a whole lot. So what this says is you're taking the estimated minus the exact. Again, you're taking the absolute value of it. So whether you subtract them in this order or this order, as long as you take the positive version, it will be the right answer, okay? So we can go 63 minus 61.5. Which number goes on the bottom here?
the exact.
The exact. What is your exact? The 61.5. Okay, so just make sure that's the biggest difference now. It's not the one you started with. It's not your original amount. It's the exact amount. Okay, so subtract that, 63 minus 61.5. And then you divide that 1.5 by 61.5. So plug that into your calculator and you should get 0.02439, if I plugged it in correctly anyway. What is that as a percent? 2.4, right? Multiply it by 100. So we would say your relative error, I did this one to the nearest tenth just because I don't know why. It didn't say. If you said about 2%, that would be fine. I'll try to make sure that on a quiz or a test, I tell you where to round it. If I don't tell you, I won't be picky about where you round. So what is the percent error in the estimated height? We were about 2.4% off on our own height, if this was us in the problem. Okay, that's the error that we made. Okay, so then this one, you think that the distance between your house and a friend's house is 5.5 miles. The actual distance is 4.75 miles. What is the percent error in your estimation? What goes on top?
5 minus 4.75.
Yeah, find the difference, right? 5.5 minus 4.75. And again, if you prefer to do it this way, you can do the absolute value of the estimate minus the exact, but I think it makes a lot more sense if you just do bigger minus smaller, and that will be the absolute value version, okay? That will be your positive amount. Which one goes on bottom here?
4.75.
The actual amount, 4.75. So you plug that into your calculator. So 0.75 over 4.75. What do you get?
0.1578.
So as a percent error, about no, it just means it just means approximately. About
I thought it would have been a cross, but that's it.
yeah.
Wait, I thought approximately and about were two different things. No, they're the same.
About is
I
like
thought approximately was exact.
no, approximately is like close to.
But it's not a percent.
Yeah.
Because it says the percent.
Yeah, percent.
Oh,
This is my percent symbol. Sorry, I always make my
yeah, it
It-
does look like a 7.
I make it kind of look like a 7. Sorry, I always put I go like that. Sorry, percent. No, sorry, those are my percents. I'll try to stop doing that, but I've been doing that for 18 years. I don't see it stopping now. We'll see. Just remind me when I do it and I'll write it the other way. Any questions on that? Okay.